Come. So let's go on to settle 11 and 12. So previously, right, our questions involve the Venn diagram, involves basic counting, okay, and then involves some proof that two events are independent, two events are mutually exclusive or not, and then we deal a little bit of conditional probability, right? So now we are at the place where we are merging different conditions together or merging different properties together. So you just need to focus on what are the properties of probability, which is, or what are the some basic ideas of probability, and what are some types of questions there are in probability. So the types of questions, right, we have seen counting, the card ones. We have seen counting also by counting like counting odd number, even number, square numbers, addition, subtraction, division, those kind of things. We also deal with Venn diagram. We also deal with tree diagram. Okay, so yeah, and then question 10, right? Choosing choir committee. Okay, that one would require us to do counting in terms of permutation and combination. Okay, so likewise for 11. Okay, let's see. Okay, likewise for 11, our P&C chapter is alive here as well. Okay, so at the passing out parade ceremony for the newly appointed officers of cadet of SAF, we have 3 Malay officers, 3 Indian officers, 2 Eurasian officers, 7 Chinese officers were asked to take a photograph. If the officers are to stand in a row, find the probability that no Chinese officers are next to each other. Okay, so let's analyze and see what is the situation like. So we have 3 Malay, 3 Indian, 7 Chinese, right? So in total, how many people? In total, we have 13 people, right? 13 people in total. Okay, 13 people in total. We have 3 Malay, 3 Indian, 2 Eurasian, and 7 Chinese, right? Okay, so if we were to arrange them, right? Yeah, 15. Oh, my bad. My, 3, 3, 2, 7, 14, right? No, 15, 15, 15. 15, my math. Okay, can. Okay, can. 15 people, thank you. Okay, so right, what happens is that let's figure out if they were to, like, if there's no Chinese officers next to each other, right? Okay, racial harmony, but how, okay, what's the situation like? What's the arrangement like? Okay, okay, total number of ways to arrange without restriction. Okay, so we are arranging 15 people, so this would be 15 factorial. Okay, let's arrange the non-Chinese first. Okay, so non-Chinese, 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 non-Chinese. So for them to not be together, we will deploy the insertion method, the one where you insert in between. Like that. Okay. Then, right, because of this, we have how many gaps? 1, 2, 3, 8 of them. Keep it out. Sorry, 8 non-Chinese. Okay. And then how many gaps do we have? 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 gaps. Okay. So this will be 9 gaps, arrange 7 people. Okay. So this one will be to arrange 7 Chinese in 9 spots. Okay. My bad. Sorry. Okay. Can. So the required probability would be, okay, for this situation, 8 factorial multiplied by 9p7 divided by 15 factorial. So all this together will give us a very weird number, 4/715. Okay, let's look at number 2. We want to arrange such that the Malay officers are next to each other. So means that the 3 Malay officers, right, they will form a group. Okay, and we will permutate and arrange by the units. Okay, so how would this look like over here? Okay, so let's say if we have do, re, mi, fa, sol, la, ti, do, re, do. Okay, cannot, too high. How many? 13, 14, 15. Okay, can. So technically speaking, if the 3 Malay people are here, they will form one group, correct? And then we have other gaps to permutate, right? Correct? So, okay, sorry, I put here. Okay, so this one for this situation, how many ways to arrange? So ways, okay, number of ways to arrange, okay, would be, okay, for, let's permutate the 3 Malays first. So this one is to 3 factorial, okay, arrange 3 Malays, okay, and then how many people are we arranging? We'll be arranging 12 and this group, because this group can go anywhere, correct? So it means that we will be arranging 13 groups. So it will be 13 factorial. Okay, so this will be 12 people and one group. So total 13 factorial. Can hall. Okay, so with this, right, so the probability that we want, okay, would be 3 factorial times 13 factorial divided by 15 factorial, which is the total number of arrangements. So this will be 1 over 35. Okay, a bit too low, but can so what we want divided by total number of cases, then like that probability. Okay, can so the P and C thing would be, yeah, would be a challenge lah for probability. But for the rest, we just need to be able to count better or to form the Venn diagram better. Okay, that will be part 2. Okay, part 3, the 2 Eurasian officers are at the 2 ends. Okay, so let's look at this case. Okay, so we need to have a Eurasian person, right? And then we need to have the rest over here. Okay, the rest of them standing over here. And then one more Eurasian person, right? Can Okay, let me erase, change color. Okay, so now how many ways do we arrange this? Okay, so first, let's try to arrange the 2 Eurasian people first. Okay, how many Eurasians do we have? We have 3 people. We are arranging them in 2 slots. So this is 3 choose 2 times 2. And there's only 2 Eurasian. Okay. Then it will be just 2 lah. Right, 2 of them. Okay. So this will be 2 times. Okay, thank you. Okay, then how many people in between? 13. So this will be 13 factorial. Okay, so the probability would be just, okay, 2 times 13 factorial divided by 15 factorial. So this is 1 over 105. Okay, last one, find the number of ways. Okay, so this one, part B, right? We are not looking for probability, we are looking for the number of ways that the officers can stand. So it's not a probability question. Okay, A is probability, but for this one, it's not probability already. So find the number of ways the officer can stand in 2 rows such that all the Chinese officers in the back row, while all the other 8 officers. Sure, okay, can. What's this ratio? How many things? Okay, can. So what happens would be, okay, so how do we arrange? Okay, so we have the back row, and then we're going to have the front row, correct? Right? So we need to arrange the back and the front separately lah. Okay, sorry, I shouldn't do this. Okay? Right, so the number of arrangements, okay, would be, okay, how many ways to arrange the Chinese people? 7 factorial. Okay, how many ways to arrange the non-Chinese people? 8 factorial. Okay, and then there's no restriction whichsoever, so it'll be just like that, and we count them separately. Okay, so it'll be just okay, it'll be very big lah, so I think we can leave it like that. Okay, otherwise, right, the other way, 7 factorial multiplied by 8 factorial is Okay, if you want to write everything 2032122800, but no need lah, huh? Yeah, 7 factorial times 8 factorial also can. Okay. Okay, so this will be part B. Okay. So far, any questions for 11? Can I? So once again, okay. Yeah, yeah. Mm. Okay. Good, very, very good question. Very, very, very good question. Okay. So for this case, right? Okay, you are taking all the possible arrangement, correct? Minusing the situation where you have all the Chinese together and all the non-Chinese together, correct? Something like that, right? Okay. Are there any other cases where if we minus this, right, did we miss out any cases? For example, one Chinese over here, or maybe like one here and one in the middle, that kind of thing. Do we miss out any cases? Actually, we do, right? Actually, we do. Yeah. So actually, right, we are actually missing out these cases. So we miss out, for example, we have one Chinese and then we have a group of non-Chinese, then maybe one more Chinese here and yeah, something like that, right? Or we miss out like maybe like one big group of Chinese, non-Chinese, then Chinese, Chinese, non-Chinese, like that. So we are missing out these cases, okay? But it's a very, very good technique if the question asks in such a way where find the probability that okay, so this is a very good technique if the question is phrased such a way that not all Chinese officers are next to each other. That would be a very wonderful technique. Okay, one more time. Okay, to rephrase this, to look at this question again. This question we are talking about, find the probability that none of them are next to each other. So we really have to slot them into the gaps over here. Okay, then if we are looking for not all Chinese officers next to each other, some may be next to each other, right? So this will be wonderful. We take all of them minus all of them together. Then there will be some of them together, some not together kind of situation. Yeah, we will include that in the counting. Okay, that would be wonderful. Yeah, this is a very good point because I need to, yeah, I need to, yes, this is a very, very good point because, right, I need to highlight the different ways to count. So for this one is arrangement, right? Arrangement actually quite straightforward. Okay, arranging people is very straightforward. And then arranging people, okay, for A part one and the case where Celeste brought up, okay, yeah, this one is one way to think about it. These are some few variations that we have. The other variation where we have, right, is this counting the prior one that we did last week. Okay, the combination one. Okay, so when we come to combination questions, right, more often than not, we need to list out cases. Okay, one more time. When we want to count the combinations, right, more often than not, we need to list out cases and to count one shot. Okay, whereas, so that's why the working, right, at the denominator, you find that there are two or more terms at the denominator because we need to count many different cases. Whereas for arrangement for permutation, right, more often than not, it's very straightforward. And we just count one shot. Okay, can so this will be for 11. Okay, then 12. Okay, let's look at 12. Okay, so a pupil either walks to school or travels there by bus. The probability that she'll be early or on time is 19 over 28. The probability that she'll be late, given that she'll walk to school, okay, is twice the probability that she will arrive late, given that she traveled by bus. Okay, so whenever she travels to school by bus, the probability is okay, so like from here, okay, so given that the probability that she walks to school is P, draw a tree diagram to illustrate. So this one is a tree diagram problem, okay? So what's the first stage? Walking or taking bus. Second stage, early or late, correct? Can So let's define our variables first, okay? So we have Okay, B, W, E, and L lah, huh? So this will be by bus, this will be by walking, this will be early, this will be late. Okay? Can So usually we'll need to write full sentences for this, but I think for the sake of time, I'll just do the short form. Okay? So let's draw the tree diagram first. So the first stage would be, okay, between taking bus and walking. Okay? Then there will be two situations at the end. Either she'll be early or she'll be late. Okay? Okay, now let's translate all the English into math now. So the probability that she will arrive early or on time is 19 over 28. So what does this mean? This means that the probability of early, okay, the event that she's early will be 19 over 28. Okay, but which branch is it? It is not for a particular branch. It is the total case where she's early. Okay, because the case where the probability where she's early, right, happens in two situations, right? So the sum of these two situations will give 19 over 28. Okay, and so it's not for any particular branch, but for these two outcomes. Okay, next, the probability that she will arrive late, given that she walked to school. This is the one. Okay, is twice the probability that she'll arrive late, given that she traveled by bus. Okay, so okay, I will keep that there first. Okay, this one I will leave it there first because I don't know what variable do we have. So I will keep it there first. Okay, whenever she travels to school by bus, okay, the probability that she will arrive early or on time is 3 over 4. Okay, so if she, so now, right, we have one more, okay, this sentence over here, okay, we have one more information. So if she travels by bus, the probability that she will arrive early given that she travels by bus, okay, this is 3 over 4, correct? And because this one is a conditional probability, right? So given that it is travel by bus, the probability that she's being early over here, okay? So this probability here would be 3 over 4, okay? Can Okay, and the probability that she walks to school is P. Okay, so this one over here, very direct. So this will be P. Okay, so these are the information given. Okay, 10. So now the problem is, okay, we need to find ways to, like extend the information that we have. So if this is P, this over here would be total 1, correct, minus P. Nice. Okay, can All right. Then if this is 3 over 4, this one over here would be 1 minus 3 over 4, which is 1 over 4. Okay. Now, if you are not too sure, this is probability of being early given that she takes bus. And this is the probability of being late given that she takes a bus. Okay. This is for the second stage. Okay. Then for the one at the bottom, right, this one, why is it half? Okay. So let's try to find the remaining branch over here. Okay, let's try to find the remaining branch over here. So the probability of her being early in total is 19 over 28. Here, this is 3 over 4, right? So what is this probability over here? Okay, so this one, I need to do some working over here. Okay, let's look at this one over here. Okay, this sentence over here. Okay, so the probability that she will arrive late given that she walked to school is 2 times the probability that she will be late given that she traveled by bus. Okay, so we have the information here already. This one over here, okay? This one over here, we can use it for this relationship, okay? So this would be 2 times of 1 over 4. So this would be half. Okay, my bad. Can so from here, okay, we can oh, okay, we can make use of it and put it here. Okay, my bad. Okay. Then because this is half, the other one is also half. Okay. So far we've done part 1, or more like the part 0, where we need to construct the tree diagram. Okay. So what do we need to do next for part 1? We need to find the probability that on a randomly chosen day she walks to school. Okay. Means that we need to solve for P. Can Okay, sorry, my bad. Okay. Just now this one, my bad. Okay. Okay. Okay, one more time. From here, right, is from the sentence above. The probability that she will be late given that she walk is twice the probability that she will be late given that she takes a bus. So actually from here lah, my bad. Yeah, I shouldn't have used that instead. Okay. Okay, so with this, right, now let's take a look at, okay, now we are going to make use of the one that should be early. Okay, so the probability that should be early is the probability that she'll be taking a bus and being early, and probability that we should be walking and she is early. Sorry, this should be the one, not the previous one, not the given one. Okay. So it means that if I sum up the probability that she will be early, okay, it will be 19 over 28 along the branches. Okay, sum out along the branches. So this would be 19 over 28 equals to, first one will be 1 minus P times 3 over 4. The second one would be P times half. Okay, so doing some math, your P would be equals to 2 over 7. Okay, can I? Okay, I think I'll do the math lah. Let me do the math. Okay, so this one would be 3 over 4 minus 3 over 4P plus 1 over 2P. Okay, so a quarter P would be okay, 1 over 14. So P would be 2 over 7. Okay, so this will be for part 1. Okay, sorry, my bad, this one. Okay, so this one is to sum up along the branches. So this one is E-math. Okay, part 2. Okay, part 2, we are looking for the probability that she have traveled by bus given that she arrives late. Okay, probability that she will be traveling by bus given that she arrives late. Okay, so if we make use of the conditional probability, this is probability of taking a bus and being late divided by the probability that she'll be late. Okay, so what is the probability that she will take the bus and be late, which is over here? Take the bus and be late, right? So 1 minus P times 1 over 4. Okay, so this would be 1 minus P times 1 over 4 divided by, okay, probability that she'll be late is 1 minus 19 over 28 lah. Because the probability that she'll be early is 19 over 28, so the opposite is 19 over 28. 1 minus of that law. Okay? And so this would be 1 minus the probability that she'll be early. Okay, so making use of your calculator, you can solve this to 5 over 9. Okay, very straightforward. Okay? Can conditional probability, make use of the formula. What is this? Multiply along the branches. What is this? This you refer to probability of it being early. Okay, then 1 minus early would be late. Okay? Next, part 3. Okay, part 3 is the extension. Okay, so now instead of one student, now we are picking two students. Wow, even worse. Okay, so we are going to add this to another dimension. Okay, so what is the probability that both students walk to school and are late? Okay, so instead of analyzing both at the same time, let's consider one student first. Okay, so for part 3, okay, so probability that we have one student, okay, who walks to school and is late. Okay, so what is the probability that the student walks to school? 2/7, same probability. What is the probability that the student will be late given that the student walk half, right? So this will be 1/7, correct? Where is this? Okay, I quickly show probability that the student walks to school and is late. So this will be P times half. Okay, and walk to school late. Okay, like that. So now we are picking two students. Probability that we have two students, both walking and late. Okay, so means that the first student must be 1/7. The second student is also 1/7. So this will be 1/49. So this is for the first student. This one over here is for the second student. Okay, so this one is to walk. This one is late. Okay, using tree diagram. Okay, all right. So let's look at the last one. Okay, last part. At page. Okay, sorry. Okay, last one. Okay, find the probability that we have exactly one student being late. Sorry, exactly one of the student is early, giving your answer to three significant figure. Okay, so the probability that exactly one early, okay, means that we have two students, right? So probability that the first one is early, the second student is late, plus the probability that we have the first one to be late, then the second one to be early. Okay, can all right, so what is the probability of the first student to be early is 19/28. The second one to be late will be 1 minus 19/28. Okay, or if you want to be faster, this will be 9/28. Okay, the complement. Okay, then for the second case, it will be first one being late 9/28 times 19/28. So this is EMAth, back to EMAth. But we are extending the problem to figuring out two students. Okay, can so this one over here, altogether 171/392. Question asks us to write in 3 SF, so 0.436 to three significant figures. Okay, can okay, so now for this question, right, this once again is EMAth question, but in A levels, right, it is no longer as simple as the EMAth paper 1, paper 2 kind of question. Now, what we need to do instead is that we will need to consider the tree diagram, right? But the tree diagram is only for one student. Then we need to consider for second student or other cases. Okay, plus the fact that we may need to involve conditional probability. Okay, can all right. So with this, we have completed probability. Not an easy chapter, not the easiest chapter, but it's definitely easier than P&C. It is not easy if you involve counting. Okay, but I can assure you, after P&C and probability, right, everything will be much better. Okay, binomial, normal, hypo, and correlation, regression, right, they will be much better. Okay, so don't worry so much.